Despite being 98% identical in composition to ordinary table salt, Himalayan pink salt sells for up to 30 times more, enchanting the world with its magical rosy hue and rising as a global symbol of luxury, powering an industry worth billions of dollars. But how are hundreds of thousands of tons of this precious salt mined and processed every year? That extraordinary journey begins in the vast mines hidden beneath the Himalayas, where raw blocks of ancient salt are carved from the earth. From there, they travel to modern factories and undergo a meticulous process, transforming into pure pink crystals for fine dining, or into glowing salt lamps, mystical objects celebrated in feng shui and luxury spa rituals. Today, join Agriculture Insight on a journey to the sun-drenched land of Pakistan, where we uncover the secrets behind how mankind mines this primordial fossil and turns it into one of the world's most coveted luxuries. Legend has it that in the 4th century BC, when the army of Alexander the Great marched through this land, their horses accidentally licked exposed salt rocks, leading mankind to discover the miraculous treasure hidden deep underground: pink salt. Unlike common salt formed from the evaporation of modern seawater, these pink salt deposits were created more than 250 million years ago, when ancient oceans evaporated and left behind massive layers of salt that were gradually buried and transformed through millions of years of geological activity. Despite bearing the name Himalaya, pink salt is not mined directly from the majestic mountains, but mainly from the Khewra mine in Pakistan, located hundreds of kilometers away from the Himalayan range, and supplying 95 to 98% of the world's output. Each year, this mine produces around 400,000 tons of pink salt, but compared to the estimated total reserves of 6.7 billion tons, that figure is only a tiny fraction, enough to imagine the entire deposit could provide salt to build more than 18,000 colossal Empire State Buildings. Not only distinguished by its enchanting natural pink hue, Himalayan salt is also branded as a luxury salt, thanks to its content of more than 80 trace minerals, and is believed to have the ability to treat various ailments, from insomnia, stress, and depression, to digestive disorders. However, this difference accounts for only about 2%, sparking debates that the mineral content is far too minimal to provide significant health benefits, and that most of its so-called miraculous effects are in fact the result of marketing strategies. It is from these very debates that the journey of mining pink salt becomes even more valuable, revealing the elaborate process that truly defines its worth and brings this ancient mineral from deep within the earth to light. At the Khewra mine, the method of extracting pink salt takes on a character entirely different from that of ordinary stone quarries such as granite, marble, or limestone. In those quarries, diamond wire saws, massive cutters, or even powerful blasts are often used to separate material quickly and at high output, with little concern for preserving the integrity of the crystal structure. But at Khewra, everything unfolds with almost surgical precision. First, the miners begin by manually drilling small cavities deep into the solid salt walls, a task that requires both precision and physical strength. In addition to drilling manually by hand, the miners also operate large drilling machines, pressing them firmly against the salt walls to carve deep cavities in preparation for the placement of explosives. Once the cavities are prepared, they carefully insert 4 measured charges of gunpowder into each opening, making sure the placement is exact. The charges are then connected with detonation cords, arranged in a sequence that controls the force of the blast. Finally, when ignited, the explosives release just enough pressure to detach massive blocks of salt from the rock face, while leaving their million-year-old crystalline structures perfectly intact. Each day, through the tireless labor of around 500 miners, production can reach up to 2,000 tons of pink salt. This delicacy, combined with the room and pillar method, leaving behind massive salt columns as natural supports, has turned the mining process here into an art of preserving a mineral treasure, rather than merely an exercise in industrial extraction. After the explosives are detonated and the dust slowly settles, massive blocks of pink salt emerge, shimmering with hues ranging from pure white to soft blush and radiant rose orange. The next stage of the process relies not on conveyors or modern cranes, but entirely on human strength. The most grueling task is splitting the salt blocks with heavy iron hammers and hauling them away. Miners must carefully control each strike to avoid shattering the crystals, shaping the blocks into sizes just small enough to pass through the narrow tunnels. The briny air makes every breath a challenge, draining the miner's strength 3 to 4 times faster than work on the surface. Many compare this labor to coal mining, as both demand immense physical strength, harsh working conditions, and extraordinary endurance. Yet the difference lies in the treasure unearthed. Instead of black coal, here the miners bring forth glistening, pink gems from the depths of the earth. Crystals born from ancient oceans hundreds of millions of years ago, now continuing their journey to shine once more under the sun. When massive blocks of pink salt, each weighing hundreds of kilograms, are cut free from the rock walls deep inside the mountain, they do not go straight to the factory. Instead, workers load them onto small mine carts running on narrow tracks to be transported to a vast stockyard just outside. This stockyard plays a crucial role, acting as a giant transit hub. All the salt mined during the day is piled into towering mounds and given a preliminary sorting. The clearer, more transparent blocks with fewer impurities are set aside for premium table salt, while the darker, vein-streaked chunks are reserved for industrial use or for crafting decorative salt lamps. The stockyard also helps regulate the production pace, since the factory cannot process thousands of tons of salt at once. The mineral must be safely stored before entering the modern crushing, washing, and refining lines. Thanks to this stage of transfer and stockpiling, Khewra's pink salt is not only preserved, but also quality checked right from the beginning, laying the foundation for its extraordinary transformation into the sparkling pink crystals that find their way onto dining tables around the world. From the very first step, the salt is subjected to primary sorting, a task that demands the sharp eye and skilled hands of the workers. Only the pure, translucent pink crystals of uniform color are kept, while any blocks with impurities, deep cracks, or blotchy tones are immediately discarded. Alongside the precision of human craftsmanship, the mechanical power of automated conveyor systems plays a vital role. It is this combination that allows the production line to run almost without pause, with a processing capacity of up to hundreds of tons of salt each day. After sorting, the pink salt is immediately transferred to an automated washing system. Here, high-pressure water jets are sprayed continuously across the surface of the crystals, washing away fine dust and leftover fragments from the mining stage. Below, vibrating sieves shake relentlessly to remove remaining impurities, ensuring that no unwanted particles cling to the salt. Some may wonder, Doesn't washing with water risk dissolving the salt? In fact, thanks to strict control of time and pressure, the water contact is just enough to clean the surface without affecting the solid blocks. Thanks to this cleansing step, the pink crystals emerge from the tanks with their signature shimmering hue intact, while reaching the purity required for the next stage of processing. From the washing tanks, the salt moves on to the stage considered the most powerful and dramatic: grinding. The raw salt blocks are fed into massive industrial crushers, where steel rollers weighing hundreds of kilograms slowly press down, breaking the blocks into smaller fragments. In some plants, jaw crushers are used instead, with two steel plates closing under pressures of dozens of tons, powerful enough to shatter a block of salt in just seconds. Once reduced to more manageable pieces, the salt is transferred to fine grinders. Here, blades spinning at over 3,000 revolutions per minute slice the fragments into uniform granules, producing the pristine pink crystals destined to become a refined seasoning on dining tables around the world. Once finely ground, the pink salt is fed into a sealed drying system. Inside, streams of hot air circulate continuously through each grain, gradually drawing out the remaining moisture. The temperature is kept steady at 90 to 100 degrees Celsius, just enough to ensure complete drying while preserving the natural crystal structure and the salt's signature rosy hue. Interestingly, once dried and passed through advanced optical scanners, Himalayan pink salt can preserve its quality for decades without the need for any additives or chemical preservatives. By contrast, ordinary table salt usually requires anti-caking agents such as calcium silicate or potassium ferrocyanide to prevent clumping, which makes it a product that has already been processed. This very distinction is what has earned pink salt its reputation as one of the purest salts in the world. Though praised as natural and pure, Himalayan pink salt can still contain trace amounts of heavy metals, such as lead, arsenic, or mercury. For this reason, every export batch must undergo strict testing to ensure consumer safety. In reality, the salt's signature pink hue is not the result of any miracle or mysterious property, but comes from the presence of iron oxide, Fe2O3, within the crystals. The very mineral that gives it its enchanting color and distinctive commercial value. The qualified batches of salt are immediately transferred to the semi-automated packaging area, where the entire process takes place in a sterile environment. The price of Himalayan pink salt is many times higher than that of ordinary table salt. In Pakistan, a bag of pink salt may cost only a few dollars, but once it reaches international markets, the price can soar 10 to 30 times higher, and even more for finely crafted artisanal products. The salt is divided into different product lines: fine grains for culinary use, raw crystals for spa and feng shui, and large blocks crafted into glowing salt lamps. The opening stage is crystal cutting. Massive salt blocks weighing hundreds of kilograms are placed on specialized cutting tables, facing alloy blades sharp as swords, mounted on powerful engines. Throughout the process, clean water is continuously sprayed onto the cutting point. The water serves to cool the blade, wash away salt dust, and simultaneously polish the surface along the cut. As a result, the blocks emerge clear and flawless, free of cracks, meeting the strict standards required for decorative pieces and salt lamps. To achieve this level of quality, factories rely on specialized machinery, ultra-durable cutting materials, and craftsman-level skill. These demanding requirements make the processing cost of solid salt blocks 5 to 7 times higher than that of crushed salt. This is why products made from whole salt crystals are regarded as mineral luxuries, coveted by high-end spas, the elite, and even the most demanding markets around the world. When the Himalayan pink salt blocks are cut down to medium sizes of 2 to 5 kilograms, they enter the detailed crafting stage, the step that transforms a raw mineral block into a work of art. Each block is firmly secured on a grinding table or lathe. Grinding blades rotating at 2,000–3,000 revolutions per minute carefully sculpt the surface, carving curves, grooves, or patterns according to the design. This process is a fusion of precise technique, preserving the crystal structure, and the artisan's aesthetic eye, highlighting the unique pink veins within the salt. It is only after this step that the block truly transforms, from a primitive mineral crystal into a mineral lamp, glowing with a warm pink light, serving as both a decorative piece and, for many, a source of relaxation and wellness. Today, Himalayan salt lamps are exported to over 50 countries, with the United States and Europe as the largest markets. Though many of the claimed benefits remain unproven, pink salt endures as a global luxury, cherished for its unique color and powerful cultural symbolism. China is currently the world's largest producer of salt, with an annual output of up to 70 million tons. With coastal salt fields spanning thousands of hectares, the United States ranks second, but leads in cutting-edge extraction technologies and advanced automation systems. Throughout history, salt has been far more than just a seasoning. It was once used as currency, a strategic weapon, and today remains a billion-dollar industry spanning continents. But have you ever wondered how salt is actually formed? Accounting for nearly 60% of global salt production, sea salt is the most common and accessible type. As seawater evaporates under the sun in shallow salt ponds, the salt concentration gradually increases until it reaches saturation, causing sodium chloride to crystallize into shimmering white layers that sparkle like crystal. An adult needs around 4 to 5 grams of salt per day to maintain blood pressure, nerve function, and internal balance. But when consumed in excess, salt becomes a silent killer, leading to high blood pressure, heart failure, kidney damage, and other serious complications. And now, join us as we begin the journey to the birthplace of salt, where sunlight, wind, and human hands come together to create the glistening white gold that has sustained civilizations for thousands of years. Every December, as the weather turns dry, sunny, and low in rainfall, ideal conditions for salt crystallization, the coastal salt farms begin a new production season. Farmers start by restoring the entire salt field system in preparation for the journey of harvesting white gold. Storage ponds, concentration ponds, and crystallization beds are thoroughly dredged, leveled, and reinforced with solid dikes to retain water. The pond bottoms are either paved with dark cement or compacted with clay to prevent seepage and enhance heat absorption, accelerating the evaporation process. A standard salt field system typically consists of 3 main zones: a settling pond to purify incoming seawater, a concentration pond to increase salinity, and a crystallization bed, where bright white salt crystals slowly take shape under the coastal sun and wind. Once the salt field system is ready, seawater is channeled into the first settling pond through shallow ground-level canals or pipelines connected directly to the sea. Each settling pond can hold up to 500,000 liters of water. Timing is crucial. Water must be drawn in during high tide to capture optimal salinity. A delay of just a few hours can disrupt the entire crystallization process that follows. There, it is held for 1 to 3 days to allow sediment, sand, algae, and plankton to settle, effectively purifying the water before it enters the crystallization stage. After this settling and filtration process, farmers use salinity meters to check whether the brine has reached the appropriate saturation level for salt to begin crystallizing. This precise measurement helps regulate the salt concentration, ensuring even formation and high-quality harvests. When the seawater reaches the desired salinity, it is channeled through small ditches into evaporation ponds, where natural sunlight and wind gradually evaporate the water. At the concentration pond, seawater continues to undergo natural evaporation under the combined effects of sunlight and coastal winds. As the water gradually evaporates, the salinity rises from an initial 3 to 5% to around 20 to 25%. This process can take anywhere from several days to over a week, depending on sunlight intensity, wind speed, and humidity. When the salt concentration reaches the optimal range of 24 to 26%, the brine is transferred to the crystallization beds, areas with wide, flat surfaces that are carefully treated with black cement or compacted clay to prevent seepage and maximize heat absorption. Here, the brine is maintained at a shallow depth of just 3 to 5 centimeters, an ideal level that allows sunlight and wind to penetrate effectively, accelerating evaporation in a consistent manner. After about 2 to 5 days, sodium chloride crystals begin to form from the bottom up, creating a bright, evenly grained layer of salt that's easy to harvest. Interestingly, the crystallization process doesn't occur as individual grains, but rather as thin sheets that can peel off in large flakes. In small-scale salt production areas, or regions where salt flats are uneven, with soft soil or sandy surfaces that limit the use of machinery, traditional manual harvesting remains the primary method. Simple tools like bamboo rakes, aluminum shovels, and hand-pulled carts become indispensable companions for salt farmers in their daily effort to collect the precious white gold. Salt is gathered into small piles, then loaded onto carts or specialized transport vehicles and moved to collection points in preparation for storage and distribution. The work demands endurance and precision, as it often takes place under intense sunlight, with the reflective surface of the salt field amplifying the heat and creating an extremely harsh working environment. Despite the laborious nature of the job, income for salt workers is often unstable, depending heavily on harvest volume and fluctuating market prices. Yet for those who have devoted their lives to it, salt farming is more than just a livelihood. It is a source of pride, deeply tied to the culture and traditions of coastal communities. For large-scale salt fields, mechanized harvesting is the optimal choice, boosting productivity while significantly reducing manual labor. Today, self-propelled salt harvesters, equipped with front blades and inclined conveyor systems, are among the most commonly used machines in modern salt production. These machines shorten collection time and improve transportation efficiency. Instead of serving merely as transport equipment like earlier models, modern self-propelled salt harvesters now integrate all key functions: scraping, collecting, and storing salt into a single machine. A front-mounted blade pushes the crystallized salt toward the center, where an auger conveyor lifts it into a rear storage compartment with a capacity of several tons. This type of machine is now widely used in large-scale salt fields across the United States, Australia, and several Middle Eastern countries, regions that demand high efficiency and advanced automation. Whether harvested by hand or machine, the salt is ultimately transported to storage areas where it is preserved before distribution. From there, it may be sold as coarse, raw salt or sent to refining facilities where it is processed into fine purified crystals, suitable for cooking and food manufacturing. At facilities dedicated to raw salt production, trucks loaded with salt from crystallization fields are driven directly to the material intake area. The salt is dumped into a receiving hopper connected to a conveyor system that transports it into the processing plant. Here, workers perform an initial visual inspection, removing visible impurities such as trash, seashells, stones, or other foreign objects mixed in with the salt. Next, the salt passes through a rotating crusher that breaks apart large clumps and loosens the material, ensuring more uniform grain size. The final stop is the packaging area, where the salt is measured into evenly portioned bags, then sealed using either heat sealing machines or industrial stitching to prevent moisture intrusion and allow for easier transportation. At this stage, the salt retains most of its natural minerals, making it ideal for food preservation, water treatment, or industrial uses such as chemical production, de-icing roads, and water softening. At refined salt processing plants, raw salt is first unloaded into a feed hopper, which connects directly to an automated conveyor system that carries it into the main production line. In the first stage, the salt is transferred into multi-stage washing tanks, where fresh water is used to remove fine sand, silt, dissolved impurities, and any remaining microorganisms. In some modern systems, the washing process is enhanced with vibrating screens and centrifugal separators, which help extract both heavy and light contaminants with maximum efficiency, without dissolving the valuable salt crystals. After the washing step, the salt is transferred into a tank or automatic dissolving unit to form a brine solution. Here, the salt is dissolved in hot water or a concentrated salt solution to reach a saturated state, meaning the highest possible salt concentration. The solution is continuously stirred to accelerate the dissolving process and improve efficiency. Next, the saturated brine solution is passed through a multi-stage filtration system to remove dissolved impurities such as calcium ions, magnesium, heavy metals, and any remaining insoluble residues. The filtration equipment may include settling tanks, pressure filters, sand filters, activated carbon filters, or the use of chemical precipitants like soda ash, NaCO3, or lime, CaOH2, to eliminate calcium and magnesium. To produce batches of pure white salt, the clean brine solution must be crystallized using a vacuum crystallization system or multi-effect evaporators, where temperature and pressure are tightly controlled. The evaporation of water under vacuum conditions causes the salt to recrystallize into fine, uniform granules. After crystallization, the wet salt crystals are sent through a centrifuge to remove excess moisture, producing semi-dry salt. This salt is then transferred to a hot air drying chamber, where the temperature is carefully controlled to fully dry the salt crystals without causing clumping or degradation. This drying process typically uses a fluidized bed dryer or a continuous belt dryer system. After drying, the salt may be cooled using air to prevent it from reabsorbing moisture when exposed to the external environment. Depending on its intended use, the salt is then ground into various particle sizes, such as fine salt, powdered salt, table salt, or industrial salt. Grinding and screening machines ensure uniformity and consistent quality of the final product. The salt crystals are separated into different sizes using vibrating screens or air classification, ensuring the final product meets uniformity and technical standards. Once refined, the salt is transported to an automated packaging line. This system can pack it into 500 grams or 1 kilograms consumer bags, as well as larger industrial sacks ranging from 25 kilograms to 50 kilograms. Each batch undergoes strict quality control checks, including moisture content, purity, iodine levels, and microbial presence. Products that meet the standards are stored and then distributed to the market. But you might wonder, what happens to all that water used in the process? Is it simply discarded? Not at all. In fact, modern salt refining plants are equipped with integrated wastewater treatment systems to ensure environmental safety. Wastewater from washing, filtering, and drying stages is treated using physical, chemical, or biological methods. Once purified, this water can be reused in non-food contact applications, such as cooling systems or equipment surface cleaning. This approach not only reduces operational costs, but also aligns with sustainable production standards. In addition to common sea salt, there are also rare and valuable types like Korean bamboo salt, which can cost many times more due to its unique mineral content and a painstaking production process that takes weeks or even months to complete. This unique type of salt originates from Korea and has been used in traditional medicine as a detoxifier and digestive aid. Bamboo salt begins with natural sea salt, but instead of being refined, it is packed into sections of fresh bamboo, which are then sealed at both ends with volcanic clay. These bamboo tubes filled with salt are fired in a kiln at extremely high temperatures, ranging from 800 degrees to over 1,300 degrees. And the process can be repeated 3 to 9 times depending on the grade of the salt. The first firing removes impurities, while subsequent firings enhance mineral content and trigger chemical reactions between the salt, bamboo, and clay. During the firing process, the salt changes color, from white to purple, gray, or metallic hues, and its crystal structure is transformed. It loses the harsh sharpness of regular salt and develops a more mellow taste with subtle mineral undertones. Remarkably, bamboo salt is highly alkaline, with a pH between 10 and 12, and is believed to neutralize excess acid in the body, aid in treating stomach ulcers, detoxify the liver, eliminate heavy metals, and cleanse the mouth. Compared to refined sea salt, which is primarily pure NaCl, bamboo salt is almost a controlled chemical transformation, crafted through traditional methods. Each batch can take several days to weeks to complete and consumes a large amount of raw material. Producing 1 kilogram of 9 times roasted bamboo salt may require over 10 kilograms of raw sea salt, along with meticulous labor. This explains why bamboo salt commands such a high price, especially the 9 times roasted variety, which can cost as much as $200, $300 per kilogram, and is often sold in small containers as a health supplement rather than used as a daily seasoning. Over a millennium ago, a humble mushroom was discovered in China, and today it enables the country to dominate the world with an enormous annual output of 4 to 5 million tons, accounting for more than 85% of global production. Yet beyond China's vast dominance, Japan also cultivates its own legacy. In Miyazaki Prefecture, a 70-year-old company harvests around 140,000 pounds of wild shiitake each year, where the rarest variety, known as white flower or hana donko, features cracked caps resembling delicate petals. Priced at a minimum of $400 per kilogram, fewer than 1% of these mushrooms ever reach this elite grade. Why, among hundreds of mushroom species, is shiitake so highly desired and driven by such strong demand? Compared to common mushrooms such as white button, oyster, or enoki, shiitake stands out with its dense texture, earthy aroma, higher levels of fiber, B vitamins, and especially lentinan, a rare polysaccharide that helps boost the immune system and supports cancer prevention. The closer shiitake mushrooms are to nature, the greater their value becomes. As the Japanese proverb says, "Shizen ni masaru mei nashi," meaning, nothing heals better than nature. Shiitake cultivated on logs in the forest is regarded as the pinnacle of this species hierarchy, yet sustaining and expanding this model is increasingly difficult, opening up a journey of wild shiitake cultivation that is both highly challenging and profoundly meaningful. It all begins with the harvesting of natural logs from the forest, usually oak, chestnut, or beech, hardwoods with dense fibers and rich nutrients that are ideal for shiitake to colonize. The secret to producing high-quality shiitake lies in the selection of raw logs, which must be clean, free of pests and decay, with an ideal moisture content of around 35 to 45%. After felling, the trunks are cut into logs about 1 meter long and 10 to 15 centimeters in diameter, then left to rest for 2 to 3 weeks under a well-ventilated shelter to reduce the natural antibiotic activity in the wood, a crucial step that allows the shiitake mycelium to penetrate and thrive later on. These very logs will then serve as the home that nurtures wild shiitake mushrooms for many years to come. Next comes the inoculation stage. Once the logs meet the right conditions, growers drill holes about 2 to 3 centimeters deep along the trunk, spaced 10 to 15 centimeters apart. In more modern facilities, machines are even used to drill the holes with precision and speed, allowing large numbers of logs to be inoculated efficiently, while ensuring uniform spacing and depth. The inoculum is usually a pure strain of Lentinula edodes, packed tightly into each hole, and then sealed with beeswax or hot paraffin to retain moisture and block bacteria or insects. This work is favored by the elderly in Japan, as they cherish the closeness to nature and find joy in watching shiitake mushrooms grow season after season. And among those hundreds of thousands of logs, no one can ever predict which one will yield the rare white flower variety. After inoculation, the logs are stacked or stood upright in cool, humid, and well-ventilated forests to begin the incubation phase, under ideal conditions of 20 to 25 degrees Celsius, 80 to 90% humidity, and little to no light. Over the next 6 to 12 months, the mycelium gradually spreads throughout the wood, and a single log can continue producing mushrooms for up to 6 years. The choice of wood, both common and considered delicious for the fungus, imparts a unique flavor to the final shiitake harvest. The cultivation of wild shiitake is becoming increasingly difficult, coupled with a steady decline in domestic demand in Japan. They require extremely strict environmental conditions, where even a few drops of rain can damage the caps and drastically reduce their value. Therefore, to preserve the perfect quality of the white flower or hana donko, growers must provide absolute protection, as even a single rainfall that alters its color is enough to strip the mushroom of its value. In the past, shiitake mushrooms were typically cultivated directly in the forest, but to better control the environment, many farmers have innovated by creating artificial log yards, outdoor areas with protective roofing. The key to this cultivation method lies in replicating the natural forest environment under controlled conditions, allowing the mushrooms to thrive while avoiding direct rain or harsh sunlight. Therefore, after months of mycelium spreading through the logs, growers stimulate them by soaking the wood in cold water, creating a shock that triggers clusters of fruiting bodies to sprout within just a few days. Though superior in quality, log-grown shiitake cannot meet rising demand, leading to industrial cultivation on artificial substrates as an efficient, scalable, and high-yield solution. The first step in the process is preparing the substrate, the medium where the mycelium will develop and form fruiting bodies. The common raw material is sawdust from non-resinous hardwoods, combined with additives such as rice bran, cornmeal, bagasse, lime, and trace minerals. Once the mixture meets the required standards, it is packed into heat-resistant plastic bags or plastic bottles depending on the model, each weighing 1.2 to 1.5 kilograms. The substrate bags are placed into a high-pressure sterilizer and treated at 121 degrees Celsius for about 2 hours to completely eliminate bacteria, wild fungi, mold spores, and insect eggs. Once cooled to below 30 degrees Celsius, an automatic punching machine creates inoculation holes at the center to standardize the process. After inoculation, the bags are neatly arranged in a dark or enclosed incubation room, maintained at 22 to 26 degrees Celsius with 70 to 80% humidity and no light. Over 45 to 60 days, the mycelium grows vigorously, spreading evenly across the entire surface of the bag and forming a fine white network, ready to enter the fruiting stage within the next 5 to 8 days before harvest. When the shiitake caps reach their ideal stage, fully expanded but with edges still slightly curled inward, dry surface with a characteristic dark brown color and firm sturdy stems, growers begin harvesting. Harvesting shiitake is a race against time, where only those who catch the exact golden moment can preserve its unmatched flavor and value. Whether cultivated on logs or in substrate bags, the mushrooms are always picked by hand to prevent damage to both the fruiting bodies and the substrate beneath. Timely harvesting is a crucial factor that directly affects the flavor, texture, and commercial quality of shiitake. If left too long, the caps expand excessively, losing firmness, tearing easily, and diminishing nutritional value. Under standard conditions, each harvest cycle can last 2 to 5 days, with mushrooms sprouting continuously and unevenly. For log cultivation, each log can be re-stimulated after a resting period of about 20 to 30 days, typically producing 2 to 4 flushes per year and maintaining yield for 3 to 5 years before the wood decays. After harvest, shiitake varieties such as white flower, donko, or koshin are placed in crates and transported to processing facilities like Sugimoto to ensure optimal freshness. The time from harvest to initial handling is usually kept within 4 to 6 hours to prevent dehydration, cap wrinkling, and loss of quality and natural sweetness. At the factory, fresh shiitake are poured onto sorting conveyors, where damaged, broken, undersized, or pest-affected mushrooms are removed. For producing dried shiitake, the most popular product in international markets, the caps are placed into hot air dryers or freeze-drying chambers to intensify their natural umami flavor. The dehydration process breaks down cell walls, releasing and concentrating aromatic compounds, making dried shiitake richly flavorful even after rehydration. After drying, workers hand-sort the mushrooms by color, size, and shape. To qualify as white flower, the mushrooms must be absolutely flawless. What sets Hana donko apart is the unique cracking pattern on the caps. While all donko mushrooms have fissures, only the white flower variety features evenly distributed cracks that resemble delicate petals, a rarity that drives their sky-high value. Other mushrooms with cosmetic imperfections are processed into shiitake powder, a product highly prized by chefs worldwide for enhancing dishes with a natural boost of umami. From the deep forests of Miyazaki to lavish banquets abroad, the journey of Japanese shiitake mushrooms tells not only a story of cuisine, but also of resilience, refinement, and the ambition of a 1,000-year-old craft reaching out to the world. From the port, the sacks of cockles are swiftly transported straight into the processing plant, where a rigorous cleaning process begins, preparing them for the next stage of production. Cleaning blood cockles is a task that demands meticulous attention to detail. Unlike clams or mussels that lie close to the mud's surface, blood cockles bury themselves 5 to 10 centimeters deep, their dark shells lined with coarse ridges that trap mud, sand, and microorganisms. Even after being rinsed at sea, they must still undergo 2 to 3 cleaning stages in the plant. High-pressure spray conveyor belts, continuously rotating shell scrubbing machines, and recirculating settling tanks filled with filtered seawater. A single lapse in this process could allow the water trapped inside the shells to become a breeding ground for bacteria. That's why, in modern facilities, automated sensors constantly monitor temperature, cleanliness, and processing time, ensuring that by the time they leave the line, each cockle is clean from its rugged shell to the sweet flesh within. Only after passing through strict cleaning and inspection stages are the blood cockles moved into the steaming chamber, where every second and every degree of heat is monitored by automatic sensors. Amid the billowing white steam of the industrial line, thousands of live cockles are cooked inside a sealed heating chamber, kept steadily at 100 to 110 degrees. After leaving the steaming chamber, the piping hot blood cockles are fed into an automatic shelling machine, where the heat helps the shells pop open for the soft rollers and sensors to work quickly, keeping the meat intact. With a capacity of up to 1 ton per hour, the process is far cleaner and faster than manual shelling. The mixture after shelling is sent into a spiral separator, where water washes away mud and light shell fragments, while the heavier meat sinks to the bottom and continues to the next stage. Once the shells are removed, the cockle meat still contains impurities, from broken shell pieces to the dark-colored innards that can cause odor. For this reason, all of it is sent into a long water trough, where a constant, powerful flow washes away grains of sand, tiny shell fragments, and even slime lodged in the folds of the meat. The water pressure is carefully calibrated, strong enough to clean thoroughly without breaking the meat. This is not just rinsing, it is a filtration of purity. In each 500 to 700 kilograms batch, even a few % of unremoved innards can lead to the entire shipment being rejected when exported to markets like Japan or Norway. Although machines handle almost all the cleaning, the next step still requires the human eye, precise, flexible, and impossible to program. Along the moving conveyor, each worker has only a few seconds to spot and remove broken pieces, abnormally small meat, or those turned brown from overheating. Immediately after sorting, the blood cockle meat is either dried at 60 to 70 degrees Celsius or flash frozen at -40 degrees Celsius in under 30 minutes. Both methods are designed to lock in freshness, preserve the signature red color, and prevent protein oxidation, the cause of off flavors and blackening. Drying caters to Asian markets that prefer a chewier texture, while freezing is the gold standard for exports to Europe. Whichever method is used, this is the step that seals in value, capturing the flavor at its peak, right after leaving the ocean. After drying or freezing, blood cockles are packed in a sterile environment, either vacuum sealed or placed in airtight packaging. Depending on market demand, they are sorted into various sizes and types, from small retail packs to large cartons for restaurants and export. In addition to drying and freezing, a portion of the catch is canned for long-term storage and convenience. After cleaning and shucking, the meat is lightly steamed or blanched to preserve its flavor, then packed into tin cans along with a preservation medium such as brine, oil, or seasoned sauce. The cans are hermetically sealed and heat sterilized at 115 to 121 degrees Celsius, completely eliminating microorganisms and extending shelf life for several years without refrigeration. This process locks in the cockle's natural sweetness, signature color, and nutritional value, while allowing them to be transported anywhere in the world.